Hi there, my name is Nico Bast and I'm a postdoc researcher at the Department of Child and Adolescent Psychiatry here at the Goethe University in Frankfurt, Germany. I have also been associated with the Aims to Trials project, one of the biggest autism research projects here in Europe. And we have recently been able to publish a study in the Journal of Child Psychology and Psychiatry, which has the title Saccade, Dysmetria indicates attenuated visual exploration in people with autism. In the following, I want to explain the title to you by walking you through the study. So, we have been known for quite a while that people with autism look differently at scenes. So, they tend to look less on socially indicative stimuli like biological motions or eye regions of their social interaction partners. So we know quite well how people with autism distribute their visual attention. But we know surprisingly little on the why this is the case. This was the motivation for the study, and we thought we should go back to basics and explore oculomotor function, which is the eye movement that defines how you are able to distribute your attention. What did we do? We showed our participant two types of movies. It were naturalistic movie clips that either contained humans or did not show any humans at all. We showed these videos to the EU Aims Leap sample, which are a couple of hundred of participants in the age of 6 to 30 years that have been assessed across Europe in the last years. While showing these video clips to our participants, we tracked their eye movement with an eye tracker. And the eye tracker is able to assess three main features of oculomotor function: fixations, saccades, and pupil dilation. So the fixation is when your eye is at rest and is the main source of visual information intake. A saccade is a fast movement of the eyeball which reorients your visual attention. And pupil dilation, apart from luminance adaptation, also indicates cognitive processes like cognitive load. So we explored in linear mixed model whether there are differences on these oculomotor features in people with autism compared to neurotypical controls. What did we find? Interestingly, we did not find any differences in fixation or pupil dilation features, and we are convinced that this is a true null findings because we had a sufficient power with around 300 individuals in our study. But what we did find was a different saccade behavior. People with autism tend to show shorter saccades and saccades that have a smaller amplitude. More importantly, this was independent of the video content. So no matter if there were humans or no humans, in the movie clips, the people with autism had these different saccades. And it indicates that it cannot be explained by attenuated social attention. We are convinced that our findings may suggest that people with autism show a different visual exploration of scenes. When your saccades are shorter and don't go that far, your fixations will stay spatially cluttered. So people with autism tend to be less able to explore a scene. And this is independent, as I said, if there are humans or no humans in it. This different functioning of saccades is controlled by a subcortical network, the pontocerebellar oculomotor network. And this network has been neglected in previous imaging research because it's so deep in the brain and difficult to track. So we may suggest that we should focus on this subcortical network in the future. And we think that our findings of attenuated visual exploration may explain a lot of cognitive findings that we have in autism. For example, an increased focus on local features, an attenuated perception of global features, and the delayed reorienting of attention. So this might all be due to a different saccade behavior, this saccade dysmetria. We know that our findings are limited. We excluded individuals that were below clinical cutoffs, so our findings are not representative of the broader autism heterogeneity. And we did not explicitly relate oculomotor function to social attention. So our findings need replications in independent samples, but we are the first to show that the visual exploration of people with autism is different, and this difference is due to a different saccade behavior. So if you have any questions on this study, feel free to send me a message, and thank you all for listening.